Hi, this is Rich with insideHPC. I'm here with Peter Dueben from ECMWF, that's the European Center for Medium Range Weather Forecasting. Peter, thanks for coming on the show today.
Thank you very much for having me.
Well, thanks for coming on. So, my first question has to do with AI. We understand that to do artificial intelligence, you need lots of data, and it would seem that you guys have lots of instrumentation. How does AI come to play in weather forecasting at your institution?
Yeah, as you say, I mean, we have an enormous amount of data in principle. I think we have something like more than 200 petabytes of data lying in our archive. And on the other hand, we have this, very complex Earth system, right, where you have a lot of different components interacting with each other that are following nonlinear chaotic behavior. And this is kind of a huge playground for machine learning methods in principle, right, because you have all those components where you can one way or the other apply machine learning techniques to. And as you said before, we have a lot of data that we can harvest if you want to actually kind of build sufficient tools.
So, when we talk about AI in this context, are we trying to notice trends in order to give more accurate forecasts, or what's the goal?
So basically, there are a huge number of potential application areas for machine learning in numerical weather predictions. And one of them is, for example, what you just said, that you want to kind of bias correct your forecast. For example, you want to learn how the forecast is biased in a specific time of the year, or under a specific weather regime. You can also kind of do what we call downscaling, which is different to the machine learning downscaling, where you actually kind of try to artificially increase the resolution of your predictions by kind of adding, for example, information about the location and, for example, the very local topography into the mix with model output data, and to kind of get better results. But really, machine learning applications and potential areas of where machine learning applications could kind of beat conventional tools are spread all over the workflow of numerical weather predictions, coming from observation handling to data simulation, where you fuse observations with a forecast model, to kind of efficiency or model improvement of the forecast model itself, and also post-processing. And even, I mean, at the European Weather Center, we also have like a huge supercomputer where you also have a lot of applications for machine learning principle. For example, if you want to kind of optimize your schedule of jobs and all these kind of things.
So, Peter, where is this going? I mean, as you develop these tools, will they become part of the daily forecast in the end, or what do you think?
That is an excellent question, actually. I mean, at the moment, science is at a stage really where we have to explore the space, right?
Yes.
We haven't kind of done a lot of tests yet with kind of very deep neural networks, for example, in our forecast prediction tools. And we're now kind of exploring the space to understand really where machine learning will make a difference and where it will be much better than conventional tools. But in a lot of those areas, we don't know yet. So we actually need kind of a couple of years of research now to really understand where it's going to make a difference and where not. And I'm absolutely confident that there are going to be machine learning tools within the numerical weather prediction workflow at ECMWF in 5 years from now. Probably in 1 or 2 years, we actually have now the first neural networks going into operations. But I can't really tell you a lot in terms of where they are going to be specifically, because we may or may not find out that some of the most promising avenues are not working, whereas others, where we didn't really thought about it in the first place, are going to be much better than we thought at the end. So it's an open game, I guess.
Okay. Well, Peter Dueben, hey, I really appreciate your time. I know it's late there, and thanks for coming on the show today. We'll see you soon.
You're welcome. Thank you very much.